students. In today's class, we shall discuss about properties of definite integrals. What are the properties of definite integrals? It is property number 1. Property 1, independent of variable. Independent of variable, that is integral a to b f of x into dx equals integral a to b f of t into dt. So independent of variable, x variable here, t variable. Proof: let integral of f of x into dx is equal to f of x, capital F of x. This implies taking limits integral a to b f of x into dx equals f of b minus f of a. So now call it as equation number 1. So now put x is equal to t. Put x equal to t. Differentiate with respect to x. Dx is equal to dt. When x equal to a, then t also becomes a. When x equal to b, then t also becomes b. So therefore integral of a to b f of x is t into dt, that is also equals f of b minus f of a. So called as equation number 2. From equation 1 and 2, from equation 1 and 2, so we get integral a to b f of x into dx equals integral a to b f of t into dt. Hence proved. Then next, property 2, change of limits or interchange of limits. The first property independent of variable, second property interchange of limits. That is integral a to b into f of x into dx is equal to minus integral of b to a f of x into dx. Integral a to b f of x into dx is equal to, so limits, interchange the limits. So lower limit here b, upper limit is a interchange the limits, that becomes minus b to a f of x into dx. Here also proof, let integral f of x into dx equals capital F of x. This implies integral a to b f of x into dx is equal to f of b minus f of a. Again this implies integral a to b f of x into dx equals f of b minus f of a. So write first minus f of a, interchange the terms, place f of b. Again this implies integral a to b f of x into dx equals, taking minus common, f of a minus f of b, f of a minus f of b. So therefore, or this implies integral a to b f of x into dx is equal to minus f of a minus f of a minus f of b. This can be written as integral of b to a f of x into dx. So therefore integral a to b f of x into dx is equal to minus integral b to a f of x into dx. This is interchange of limits. Then property 3, integral a to b f of x into dx equals integral a to c f of x into dx place integral c to b f of x into dx. Integral a to b f of x into dx can be written as sum of two integral terms, that is integral a to c f of x into dx plus integral c to b f of x into dx. Proof: let integral of f of x into dx is equal to capital F of x. This implies integral a to b f of x into dx is equal to f of b minus f of a. So now call it as equation number 1. And integral a to c f of x into dx can be written as f of c minus f of a. We call it as equation number 2. And also integral c to b f of x into dx is equal to f of b minus f of c. So call it as equation number 3. Adding 2 and 3. Adding equation 2 and 3. Integral a to c f of x into dx plus integral c to b f of x into dx equals f of c minus f of a plus f of b minus f of c. Plus f of c minus f of c gets cancellation. Therefore integral a to c f of x into dx plus integral c to b f of x into dx equals minus f of a plus f of b. Therefore f of b minus f of a. Therefore, or that is equals integral a to b f of x into dx. Then property 4. Property 4. Integral a to b f of x into dx is equal to integral a to b f of a plus b minus x into dx. So proof: so let I is equal to integral a to b f of x into dx. So now put x is equal to a plus b minus t. Put x is a plus b minus t. Differentiate with respect to x. 1 is equal to 0 plus 0 minus dt by dx. Therefore dx is equal to minus dt. When x is equal to a, t equals a minus a, or x equal to a minus a gets cancellation, t equal to b. When x is equal to b, b cancellation, t equal to a. So substitute in given integral, therefore I equals integral x is a, t is b, x is b, t is a, it is f of x is a plus b minus t, dx is minus dt. Therefore I is equal to integral, take outside minus, integral b to a, f of a plus b minus t into dt. Now by using property 2, interchange the limits. I is equal to integral minus integral b to a. So interchanging these limits, so we get minus into minus plus, it is integral a to b f of a plus b minus t into dt. Now by using property 1, independent variable, therefore I is equal to integral a to b f of a plus b minus x into dx. Hence it is true. The next property number 5. Property 5, that is integral a to b f of x into dx, it is equal to integral a to b f of a minus x into dx. Let I equals integral a to b f of x into dx. So now put x is equal to a minus t, a minus t. Differentiate with respect to x. 1 minus dt by dx. Therefore dx is equal to minus dt. When x is equal to a, x equal to a, t equal to 0. When x is equal to b, t equals, when x is equal to, when x is, here 0, to a, 0 to a, limits 0 to a, 0 to a, right. So let I is equal to integral 0 to a f of x into dx. Put x is equal to a minus t, differentiate with respect to x, 1 equals minus dt by dx, therefore dx is equal to minus dt. When x is equal to 0, t equal to a, when x is equal to a, t equal to 0. Therefore, substitute in given integral, x is 0, t is a, x is a, t is 0. So, f of a minus t into minus dt. Therefore, I is equal to, take outside minus, integral a to 0 f of a minus t into dt. So now by using property 2, therefore that is interchange the limits, that is integral 0 to a f of a minus t into dt. Therefore I is equal to, by using property 1, independent of variable, integral 0 to a f of a minus x into dx. Then property 6, that is integral 0 to 2a f of x into dx, that is equals integral 0 to a f of x into dx plus integral 0 to a f of 2a minus x into dx. Integral 0 to 2a f of x into dx equals integral 0 to a f of x into dx plus integral 0 to a f of 2a minus x into dx. Let integral 0 to 2a f of x into dx. This integral term can be written as integral 0 to a f of x into dx plus integral a to 2a f of x into dx by using property 3. Integral a to b f of x into dx is equal to integral a to c f of x into dx plus integral c to b f of x into dx. Put x is equal to 2a minus t in the second integral term. In the second integral term on the right hand side. Now differentiate with respect to x. Dx is equal to minus dt. When x is equal to a, then t equals a. When x is equal to 2a, t equal to 0. So therefore, integral 0 to 2a f of x into dx is equal to integral 0 to a f of x into dx, right, as it is first integral term, plus second integral term when x is a, t is a, and when x is 2a, t is 0. So f of x is 2a minus t into minus dt. Therefore, integral 0 to 2a f of x into dx equals integral 0 to a f of x into dx, taking minus, plus into minus, minus integral a to 0 f of 2a minus t into dt. So therefore, integral 0 to 2a f of x into dx equals integral 0 to a f of x into dx. Now by using property 2, interchange of limits, plus integral 0 to a f of 2a minus t into dt. So therefore, integral 0 to 2a f of x into dx equals integral 0 to a f of x into dx plus integral 0 to a. Now by using property 1, independent of variable, it is f of 2a minus x into dx. Hence it is proved.